We see your face, but you didn't share your screen. So,
Okay, let me try that again.
okay, now we do see it.
Fantastic.
Perfect. We are listening.
Again, hello everyone. My name is James Murray, and I am an educational technologist and the intern coordinator for the Quantum Biology Laboratory at Howard University, working alongside our principal investigator, Dr. Philip Kurian. For those who may have attended yesterday's poster session, thank you for joining us again. Today, I will provide a brief overview of our internship and training ecosystem and highlight how it supports both matter to life research and the development of future leaders in quantum science. Over the past 3 years, with support from the Alfred P. Sloan Foundation's Matter to Life program and the Howard University Graduate School, we have developed a tailored internship program that introduces undergraduate and graduate students to quantum biology through authentic research experiences. Our approach is summarized in the training ecosystem shown here. We begin by recruiting students through multiple pathways, including K-12 outreach programs such as our quantum math camps, undergraduate research opportunities, and partnerships with programs such as the IBM HBCU Quantum Center. Students then receive mentorship through a tiered support system that includes graduate student mentors, postdoctoral scholars, yours truly, the intern coordinator, senior researchers, and the principal investigator. This mentorship supports interdisciplinary research across quantum optics, biomolecular computing, protein spectroscopy, slime mold computation, and theoretical physics. Finally, we help students develop into future leaders who pursue graduate study, research careers, and professional opportunities in emerging quantum fields. Over the first 3 years of the program, we have mentored 12 interns, supported 3 first author peer-reviewed publications by interns, worked closely with 2 postdoctoral scholar mentors, and contributed to more than 25 research presentations across national and international conferences. The example shown here highlights the diversity of intern research ranging from quantum-enhanced neuroimaging and protein photophysics to slime mold computation and quantum information processing. A major focus of our current work is the Sloan Foundation's Matter to Life initiative. Our laboratory investigates Physarum polycephalum, a unicellular slime mold whose remarkable problem-solving abilities provide a unique platform for studying information processing in living systems. 2 postdoctoral scholar mentors contribute directly to this work. One studies morphological computation, exploring how the physical structure and dynamics of slime mold can inform computation. The other develops theoretical frameworks in open quantum systems and quantum thermodynamics to better understand non-equilibrium processes in living matter. We also remain committed to expanding the quantum biology pipeline through our quantum math camps. Supported by the IBM HBCU Quantum Center, these camps introduce students in grades 1 through 7 to quantum biology concepts through inquiry-based learning, hands-on activities, and field experience at Howard University. The photographs shown here illustrate several outcomes of the program, including student presentations, conference participation, international engagement, and outreach activities. In summary, our model can be described in 4 words: recruit, mentor, research, lead. By combining meaningful mentorship with authentic scientific research, we aim to broaden participation in quantum biology while preparing the next generation of researchers to address fundamental matter-to-life questions. I would like to conclude with a quote from our principal investigator, Dr. Philip Curian. Only those who can see the invisible can do the impossible. Following my presentation, you will hear directly from 4 members of our research team, Dr. Mohsen Azayari, Margie Christ, Rania Jones, and Abdul Malik Salid. Together, their presentations will provide examples of how this training model translates into active research contributions within the Quantum Biology Laboratory at Howard University. Thank you, and I'm willing to entertain any questions.
We have one question.
Hi, thank you for the great work and great presentation. I noticed on your slide you mentioned grade 1 to 7 students doing experiments. Could you give example what kind of experiment you're having students at this age do to motivate them into quantum biology?
Well, sure. We do a number of experiments dealing with light, dealing with prisms, dealing with lasers. So we do a number of experiments in that way. We have a whole model of how we develop quantum intuition in young learners. One example would be how we ensure that our youngsters are able to get a conceptual understanding of the science without having the complex mathematical ability to do so. So we prioritize clarity over accuracy. And that is one of our principles we use to introduce these very fundamental concepts to our youngsters. In year 1, we did work around photosynthesis. We also leveraged the power of virtual and augmented reality, put the goggles on the youngsters and allowed them to explore the phenomenon. In year 2, we looked at avian magnetoreception. This summer in July, our students will be exploring superradiance and protein fibers.
Can I ask the second question?
Of course.
Thank you very much. This is very cool. And I have a second, I'm also into the teaching industry. So I have a second question. I see a lot of competition in universities, especially in the US, in Canada, and I've traveled and worked in South Africa, all over the world. But my point is, in your training of these students to introduce field like quantum biology is definitely a great thing. I love this. But are you also preaching, like showing students about collaboration, how to work with each other instead of competing with each other? Is this present in your program?
Well, absolutely. It's always going to be about how do we build community within the field. I will say to you, our students who are involved in the program, they are talented and gifted students that come primarily from our urban centers in the US. So these are students in public schools here in the United States who are high achievers. And so we bring them together from multiple schools within school districts to do this work.